this will be the final part for this lecture. So we will have a look on the example of stability study. Okay, so based on the previous example that I give you, you are going to formulate a nanoparticle formulation. So the nanoparticle size is very important, and it is one of the parameter that you evaluate during the stability study. So the storage condition is 40 degrees Celsius, humidity or relative humidity set at 75%. The result obtained is as follow. At t times 0 or times at times 0, the nanoparticle size recorded was at 80 nanometer plus minus 3 nanometer standard deviation. And 3 months later, when you took a sample from the stability chamber, you tested the particle size, and the size was recorded at 85 nanometer plus minus 8 nanometer standard deviation. So you see, after 3 months, there are some changes or some increment in the particle size. 6 months later, the particle size goes up to 103 nanometer. But 9 months later, it reduced to 98 nanometer. And at 12 months or complete 1 year storage, the particle size was recorded at 120 nanometer. So you see, the size, the recorded size changes, up and down during the stability study. So how can you know if the changes are significant or not? So this is where you can conduct the statistical analysis by using the ANOVA, okay, the analysis of variance, by which you can evaluate the significance of the changes, okay, between 3 or more data. Okay, now when you fit this data into ANOVA, you will have the result, okay, that tells you whether P is equal or more or less than 0.05. If we set at 0.05 as the significance cutoff point. So if the P value is less than 0.05, so the significance between each time point is the difference between each time point is significant. If you want to know only the difference between the particle size at time 0 and times 3 months, you can use a PET t-test. Okay, so before and after storage. When you use the PET t-test, you would know whether the changes are significant or not. Or if you want to know only the significantness of the size difference between t times 0 and t at 0 and t at 12, you can also use PET t-test. Meaning that if you want to know the difference between only 2 points in the data set, you can use PET t-test because it is before and after storage. But if you want to know the difference, the significance of difference between the 5 time points, you would need to use the ANOVA so that you can really know or you can really compare between each time point. So this is another example. So you would want to produce 3 nanoparticle formula. Okay, so you have product A, product B, and product C. Product A, give a certain nanoparticle size as compared to product B and product C. If you can see here, all the material that we use to prepare the nanoparticles are the same, which are PLGA, but the difference is only in the excipient, which is the stabilizer. The stabilizer, which is the PVA or polyvinyl alcohol, the percentage of these stabilizers are different between the different products. So you prepare the 3 products with the drugs, and then you store them, and then you evaluate the particle size. And from here, you would know whether whether the particle size maintained stable during the storage, and afterwards, you can also evaluate the stability or the chemical stability of the rifampicin or the drug. And when you have the data for the chemical stability or the content of the drug, you can also conduct the statistical analysis from which from there you would know if whether the drug remains stable during the storage. The statistical analysis will also help us to determine the expiry date of a product. Okay, so the data obtained will have to be linearized and tested for goodness of fit, which we have to determine the R2 value or the R squared value in comparison to the expected data. The significance of difference between the slope will have to be determined by using t-test, pre and post treatment. Okay, I give you this example. Okay, you see the blue line is the expected stability. Okay, you have you expect the product to remain 100% concentration during the storage. The orange line refers to product 1. Okay, the product 1, you can see it reduced a bit. Okay, and at the end of 12 months, it reached 90% content. Okay, and product 2, which is the gray line, reduced even more, and after 12 months it reached at less than 80% content. So the orange dotted line is the linearized line. So if you see the linearized line for product 1, give the R squared value of 0.45 and the equation of y equal to minus 1.3 plus 100. Whilst for the grey dotted line, give you the R squared value, a higher R squared value, and with the same C value and the different M. Okay, so based from this graph and this data that you have, you can match them into this table. So if the slope between the two drugs or between the if the slope are identical and the intercept are different, okay, so the variation factor that influence the product is the batch itself. But if you refer to this graph again, the intercept are the same at 100, okay, but the slope is different, right? The slope are different. The slope of the product, okay, are different than the expected one. Okay, so hence the factor that influence the product is the storage factor. And from this graph also, you would know the expiry date or the shelf life of the product. So according to the guideline, okay, as a general rule, the stability of a drug is acceptable if the content of the drug remain above 90% of the expected concentration. So if you can see in this graph, for product 1, the concentration of the drug remain higher than 90% throughout the stability study. So we can say that the expiry of the product is at 12 months. But for product 2, at 9 months, the concentration of the drug in the product started to reduce significantly until it reached less than 80%. So from here, you can say that the expiry for product 2 is at 9 months, while the expiry for product 1 is at 12 months. So if we want to know the significantness of the difference of the concentration of each the concentration of drug in each product, we can conduct statistical analysis. As an example, if you want to know the significance of different between the drug concentration from 12 months for product 2 as compared to 9 months here, 9 months and 12 months, you can conduct PET-T test. Okay, so that would be all for stability of formulation. Um, I I wouldn't want to explain in too much detail for this topic. It's just some application, some example of application, so you would have some idea how to use statistical analysis to evaluate stability of product. Thank you.